Today's test gear teardown is a meter which I briefly showed before when I tore down the Data Precision 945 multimeter, which has the side push buttons for range selection. Now this meter also has side operated push buttons for range selection. So I promised in that video I would tear this one down, so let's go ahead and have a look inside this thing. But first of all, let's see what I got with it when I got it from the well-known auction site. Let's just turn it round there so you can see a bit of a awkward shape to film. It's got leads that came with it. It was quite grubby. I gave it a good clean. The leads are quite nice ones. They're not terribly safe. There's a couple of right angle plugs here. They've had the shrouds cut off because these are not the safety style sockets as we'd see on a modern meter. But the other end of it's a little bit unsafe because you've actually got male plugs on the end, so that's what's coming out the end of the test lead, and of course it can fall out of the insulated probe. That can fall out of there. It's not very tight. But it comes with these lovely Hirschman. These are quite dated nowadays because they really work well with quite large terminals. But if I push the button on the end, you can see, I hope there, that the little prong is coming out of the end of the terminal, and you can just grab that round the circuit you want to measure, and the thing hangs on. It's nice and long, so you can keep away from the high voltages. It's all insulated all the way along, but as I say, it is a bit slack at this point, and if that is part way out, your live potentially live circuit is a bit exposed there. That's the button. Quite a nice action. I quite like them. It's slightly flexible, made by a company called Hirschman. Way too big for any modern, say, surface mount circuit. It's actually a bit big even for a 0.1 inch or 2.54 mil DIL chip. They're really meant for big terminals. Let's fetch those off for the moment. There's the black one. Remove that, and let's have a quick look at the meter operating. If I just bring that down so you can see the display and switch on, it worked fine as a meter, as these things very often do, even though they're perhaps sold as spares or repairs or untested. This one worked absolutely fine. I've got it in ohms, so if I short that we should see it come down to 0. Yep, that's fine. Let's put it into volts and 200 millivolts, and now let's bring in the something else I need to tear down maybe at some point. This is the Time Electronics MicroCal 1030. Switch that on to the 1 volt range. The battery indicator is good, and we'll plug the meter into this and start with at 0, put it into normal mode. Now as I turn the voltage up, there we go, turn the voltage up, I should start seeing the meter reading volts, and it's reading millivolts in this range, so we're now at 69 millivolts. I think I have a slightly dodgy pot on here, and as I go up 100 millivolts, the extra digit, a half digit, shows up. Now, this is a 3.5 digit meter with an extra half digit on the front of the display there. So I keep going up. There we go to, should get to 199, and at that point it will go over range. So that's the indication we get when it's over range. A 1 in the display by itself and a decimal point as our 199 point, go on 9, there it is, and then out of range. So that's the thing functioning. I think it works okay. There's some slightly quirky features of this thing, something that I haven't seen in any other meter that I've used. If you look at the input terminals, there's a button for volts, so I'm in the volts range, 200 millivolts range. But to switch to AC volts, this just says volts. To switch to AC volts, you actually have to unplug the connector from there and plug it in there, and that makes it measure AC. That makes it measure DC. To measure current, and it can only measure DC current, to get up to the 10 amp range you need to flick the thing over into this socket. Well, that's slightly odd. I've never seen an AC DC switch by unplugging and plugging in again before. Interesting. Okay. So let's have a look at how this thing compares with other AVO products. Let's switch off there and switch off this thing. AVO is a very well-known UK brand of multimeter, and the most famous AVO product has got to be the AVO Model 8. Now that is somewhat bigger than this thing. That's an AVO Model 8. Huge, great Bakelite thing with big Bakelite switches to switch ranges. It's quite heavy. Big analog display. This thing is a 20,000 ohms per volt meter, so its sensitivity is 50 microamps, which was the standard that you would expect for a good multimeter in those days. It draws 50 microamps from your circuit when it's measuring full scale. Something like this is a much higher input impedance. The AVO, the digital AVO meter DA211, much higher input impedance instrument, much more useful if you're working with high impedance circuits. You can make measurements without affecting the operation of the circuit. Let's have a look inside. Let's get this thing opened up. Now on the back there's a label there. Let's see if we can get that in focus. AVO Limited, Dover, England. So this was made in England, in Dover. Oh, wait a minute. I'm getting confused here. This is the company address. Little tiny writing down here, it says made in Japan. So this is, although it's an English company, it's made in Japan. The labelling on the back shows that it takes a 9-volt battery and has a fuse inside. So if we open this up, sure enough there's a 9-volt battery in there, and we can remove that and get that out of the way, and then we can get the thing taken apart. There we go. That's revealed a screw, so let's take that screw out of there and put that to one side, and there's another screw down here which we can remove. Take that out. There it goes. So with those two screws out, the back will come off. That goes through there, and there's the inside of it. So we've got a fairly standard printed circuit board in here. There's a bit of screening material on the inside of the lid. There's a kind of metal foil on here, insulated on the back with this sort of brown paper stuff. So that's screening some of the sensitive electronics from external influences, and also of course stops the switching noise from this thing getting out. And that earthing wire there, we'll have to leave that connected. So what else do we have? Okay, we got one big chip. So this big chip is the 7106. I think that's a fairly standard digital voltmeter chip. Date code is 8136, so this is 1981, week 36. A Hitachi HD 14077, probably a CMOS inverter or gate of some sort, not sure what that's for. A couple of capacitors and a bunch of capacitors there. What else do we have? We have the switch. This is how the switch works. The on-off switch. So that simply, I can get that to move. Which way does it go? It goes that way. Okay, let's make that slide. There it goes. So that just slides back and forth. That's the on-off switch. Come on. There it goes. The switch itself is right angle, and there's a plastic molded thing there to operate it from the outside. What else do we have on this thing? There's an adjustment preset, so this is the calibration preset. I'm not going to touch that. We've got a fuse, ceramic fuse, not the great big fuse that you see in something like a Fluke, but a fairly ordinary ceramic fuse in there. What else do we have? Down the bottom here, this big piece of wire is the 10 amp current shunt, goes to the 10 amp terminal, and that's the 10 amp current shunt. So the 10 amp current will flow through there back to the ground terminal, and the meter will be measuring the voltage across that when the current is flowing. The side switches, which is the interesting design feature of this thing, side switches on here, very similar to the Fluke and to the Data Precision. There is a bank of switches on here, and in this case we have a second printed circuit board which is cut to fit over the switches, and that links up with these tracks on the board, links up the various switching combinations. So rather than using wiring, they've made a second PCB, only maybe a single-sided board that sits on there and makes the link connections. So that makes it quicker and easier to assemble and make sure that it's always right. When it's on the main board, we've got something there marked PTC, that's a thermistor, probably protection, some input protection diodes I think there. There's a 0.98 ohm resistor there. Fairly sparse printed circuit board layout. This isn't a massively high precision meter, being only 3.5 digit, so I'm not going to see anything terribly fancy in here in the way of parts. I can't see a separate voltage reference diode, so I suspect it's using the internal reference diode in here, because it doesn't have a separate one that I can see on the board there. The main, no, that's interesting. The main chip here is actually on a board which is separate from this board down here. There's actually 3 boards in here. There's a board with the display and the main chip, and there's a board that takes this switch and the main bank of switches underneath there, and the third board, which is this one on top of the switch bank. So 3 PCBs in total. Nice to see that there's a little brass collar, little brass threaded insert there. So that's been inserted into the plastic, and that's what the screw is doing up into. There's one at the other end again down here. So you're doing up the screw into a brass insert rather than doing it up into plastic, which is a nice feature because you have got to open it up occasionally for calibration. Can we see anything interesting on the switches? I don't think we can see much of them because they're fairly well hidden, but you can just about see them down there switching away. And only one adjustment. There's only the one calibration adjustment, so it's a very simple calibration. Set the thing up, turn that, and it reads hopefully correctly. You don't have one for each range, you don't have one for AC, one for DC, you don't have one for ohms. It's just a single calibration adjustment. Again, it's a fairly ordinary 3.5 digit meter, so it probably only needs the one adjustment. Don't see any resistors that look like the fancy ceramic based high precision resistors that we saw in the Data Precision, and which we would expect to see in something like a Fluke. So I think this is a fairly bog standard meter, nicely put together, made in Japan by a British company, sold by a British company. Date codes from the early 80s, and design based on the side push button arrangement that was made popular by companies like Fluke. So there we have it, really. That's a bit of a teardown there of the AVO DA211 digital AVO meter, a liquid crystal display, side push buttons, unusual switching it into AC by changing over the input plug there.